Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. I'm excited about our topic today. Violent tendencies and LLMs analysis via behavioral vignettes. It sounds a bit alarming, right?
It does sound a bit sensational, I'll admit, but I think it's incredibly important that we're starting to ask these questions about large language models. They're becoming so pervasive in our lives. We really have to understand their limitations and potential dangers.
I agree, it's crucial, though I'm immediately skeptical. Violent tendencies makes it sound like these things are developing agency, which I think is a dangerous anthropomorphism. What does the study actually say?
Yeah, it's definitely clickbaity language. I'm guessing it's not actually about LLMs becoming violent, but more about them generating violent or harmful content, right? And the study probably examines how these models respond to specific prompts, looking for patterns of violent or aggressive outputs.
Exactly. The study uses behavioral vignettes, short scenarios, to test the LLM's responses. They're probing for how these models might generate, perpetuate, or even amplify harmful biases and violent rhetoric.
So it's less about the LLM wanting to be violent and more about the data it was trained on containing biased or harmful content that it's now regurgitating, right? The model is just predicting the most likely next word, after all. If violent language is prevalent in its training data,
Which it absolutely is. Let's not pretend the internet is a bastion of peace and harmony, it's a cesspool. So the LLM learns to mimic that. My question is, are they just identifying the obvious stuff, or are they finding more subtle ways that these models perpetuate harmful narratives?
That's the key, isn't it? The subtlety. It's not just about overt hate speech. It's about the implicit biases, the subtle stereotypes, the way these models might reinforce existing power structures and inequalities. Are they able to translate that into harmful action, not by wanting, but by just predicting the next word?
The paper dives into that subtlety, actually. They looked at things like how LLMs respond to scenarios involving different demographic groups and whether they exhibit different levels of aggression or bias, depending on the scenario's participants.
okay, that's interesting. So they're looking at things like if you give the model a scenario involving, say, a white person and a black person, does the model's response differ depending on which person is cast as the aggressor or the victim? That would be a clear sign of bias.
Exactly. And it's not just about race, it's about gender, religion, sexual orientation, socioeconomic status, any dimension along which bias can creep in. The worry is that these models, which are increasingly used in everything from hiring to loan applications, will perpetuate and amplify those biases.
And it's not just about explicit biases either. It's about the subtle cues and associations that the model picks up from its training data. For example, if the training data consistently portrays certain professions as being dominated by one gender, the model might learn to associate that profession with that gender, even if it's not explicitly stated.
Right. The implicit associations are a huge problem because they're so difficult to detect and correct. We can't just filter out bad words and expect the problem to go away. It's much deeper than that. That reminds me of Amazon and their AI safety initiatives. It looks like a focus on memory management.
Oh? You think this violent tendencies research is related to AI safety and things like Amazon's recent announcements? It makes sense. If you can control the memory and the biases within the model, you can address a huge portion of the risk. Like you mentioned, maybe there's a shift away from just brute forcing with data.
Hold on, are we really saying that better memory management in current deep learning architectures is going to solve the bias problem? I'm highly skeptical. It's like putting a fancy new engine in a car with a fundamentally flawed chassis. You're still going to crash.
I agree with Sarah on this point. While better memory management is important, it doesn't address the core problem, the lack of true understanding. These models are just pattern matching machines. They don't understand the meaning of the words they're using, or the context in which they're being used. Without that understanding, they're always going to be vulnerable to bias and manipulation.
Okay, I see your point. It's not a silver bullet, but isn't improved memory a necessary component? If we could create AI systems that learn and remember in far more nuanced ways than current deep learning systems, wouldn't that inherently lead to more robust and less biased models? It's not just about the speed, but the depth of understanding, as I've been mulling over.
Yes, and I think the memory piece is where we can see a direct tie to AGI. Better memory management could, in theory, allow for more nuanced and complex reasoning, potentially circumventing the need for enormous datasets and computational resources. It's all connected, I think.
But nuanced reasoning still requires a representation of knowledge. a symbolic representation. These models are just giant matrices of numbers. They don't have concepts, they don't have rules, they don't have logic. They just have correlations.
And those correlations are often spurious and misleading. The model might learn to associate certain words or phrases with certain outcomes, even if there's no logical connection between them. That's why these models are so easily fooled by adversarial examples.
Can we unpack that a bit? What are adversarial examples in this context?
Sure. An adversarial example is basically an input that's been deliberately designed to trick the model into making a mistake. For example, you can add a tiny bit of noise to an image that's imperceptible to the human eye, but that completely throws off the model's classification. It might classify a picture of a dog as a cat, or even as something completely unrelated.
And in the context of language models, it could be a subtle rewording of a sentence that completely changes the meaning, but that the model doesn't pick up on. The model might still generate a response that's completely inappropriate for the altered context.
Exactly. Because the model doesn't understand the underlying semantics. It's just looking for patterns in the surface-level features of the input. That's why it's so easily fooled. It's like showing someone a picture of a zebra with a horse mask and expecting them to think it's a horse.
Okay, I see. So back to the violent tendencies study, how are they using these behavioral vignettes to expose these vulnerabilities? Can you give a concrete example?
Well, imagine a vignette that describes a conflict between two people. In one version, the people are described as being of the same race and socioeconomic background. In another version, they're described as being of different races and socioeconomic backgrounds. The researchers could then analyze the model's response to each version to see if it exhibits any biases and how it assigns blame or suggests resolutions.
Or imagine a vignette that describes a crime. In one version, the perpetrator is described as being male. In another version, the perpetrator is described as being female. The researchers could then analyze the model's response to see if it's more likely to recommend harsher punishments when the perpetrator is male, reflecting existing gender biases in the criminal justice system.
And it's not just about the explicit details of the vignette. It's also about the implicit framing. The way the scenario is described, the language that's used, the assumptions that are made, all of these things can subtly influence the model's response.
So the study is essentially trying to reverse engineer the biases that are embedded in these models by probing them with carefully designed scenarios. It's like a psychological evaluation for AI.
Exactly. And the findings could have significant implications for how we develop and deploy these models. If we know where the biases are, we can take steps to mitigate them. Maybe through data augmentation, bias correction algorithms, or even just more careful curating of the training data.
Data augmentation and bias correction are just band-aids. You're still working with a fundamentally flawed architecture. The real solution, in my opinion, is to move towards neurosymbolic AI, where you have explicit representations of knowledge and reasoning processes that can be inspected and corrected.
And that's where the spatiotemporal framework comes in, right? You need a way to represent the relationships between different concepts and events in space and time. That's what gives you the context and the understanding that's missing in current deep learning models.
Okay, let's dig into that. What does a spatiotemporal framework actually look like in practice? How would you implement that in an AI system?
Well, imagine you're trying to build a model that can understand a simple story. The story describes a series of events that happen in a specific location and at a specific time. A spatiotemporal framework would allow you to represent each event as a point in a multidimensional space, where the dimensions represent things like location, time, and the properties of the objects, and people involved in the event.
So, it's like building a mental map of the story, with locations, characters, and relationships all spatially organized.
But it's more than just a map. It's a dynamic representation that can be updated as new information becomes available. As the story unfolds, the model can update the positions of the events in the spatiotemporal space, reflecting the changing relationships between them.
Exactly. And that's where the reasoning comes in. The model can use the spatiotemporal framework to reason about the consequences of different events, to predict what might happen next, and to understand the motivations of the characters involved. It's not just about memorizing the story, it's about understanding it.
So how does this relate back to the violent tendencies study? How would a spatiotemporal framework help to mitigate the biases that are being exposed by these behavioral vignettes?
Well, imagine a vignette that describes a conflict between two people from different cultural backgrounds. A spatiotemporal framework could allow the model to represent the cultural context of the conflict, the historical relationships between the two cultures, and the potential biases that might be influencing the model's perception of the situation.
And by making those biases explicit, the model can then reason about them and correct for them. It's not just blindly applying a learned pattern, it's actively analyzing the situation and taking into account the potential for bias.
Yes, and it can compare different scenarios and reason about the generalizability of the biases, or the context specificity. It's a fundamental shift from how we do things now.
That's really interesting. It sounds like a much more robust and principled approach to mitigating bias than just trying to scrub the training data or add correction factors after the fact. But it also sounds incredibly complex. How do you even begin to build a system like that?
That's the million-dollar question, isn't it? I think it starts with better representations. We need to move beyond simple word embeddings and towards more structured representations that capture the relationships between different concepts and events.
And we need to incorporate symbolic reasoning capabilities, logic programming, semantic networks, knowledge graphs. There are a lot of existing techniques that could be adapted for this purpose.
And we need to think about how to represent and transform different coordinate systems. How do we translate between physical space, conceptual space, and temporal space? That's the key to building a system that can truly understand the world.
It makes me think about the brain itself. Neuroimaging studies show that different brain regions are involved in different types of memory: episodic, semantic, procedural. This suggests that a truly intelligent memory system might need to be modular, with specialized units handling distinct types of data.
That's fascinating. So, you're suggesting that we should look to the brain for inspiration in designing our AI architectures?
Absolutely. The brain is the only example we have of a truly intelligent system. We should be studying it closely and trying to understand how it works.
But we also need to be careful not to blindly copy the brain. The brain is the product of millions of years of evolution. It's a messy, complex system that's full of quirks and compromises. We don't need to replicate all of that complexity in our AI systems. We just need to understand the underlying principles.
Right. I'm thinking about the brain's plasticity and adaptability. It seems crucial. How can we integrate mechanisms for synaptic modification, long-term potentiation LTP, and LTD directly into the OSIS architecture to build this dynamic memory?
Okay, now we're getting into the really nitty-gritty stuff. LTP and LTD are basically the mechanisms by which the brain strengthens or weakens the connections between neurons based on experience. It's how we learn and adapt.
And the key is to find a way to implement those mechanisms in a way that's computationally efficient and scalable. We can't just simulate the brain neuron for neuron. That's not practical.
But we can abstract away the details and focus on the underlying principles. We can build AI systems that learn and adapt in a way that's inspired by the brain, but that's not necessarily identical to it.
So let's bring it back to the violent tendencies study. If we had an AI system that was inspired by the brain's memory systems and that incorporated a spatiotemporal framework, how would it respond to those behavioral vignettes?
Well, it would hopefully be less likely to exhibit the biases that are being exposed by the study. It would have a more nuanced understanding of the context of the situation. It would be able to reason about the potential for bias, and it would be able to correct for it.
It would also be more transparent and explainable. We could actually see how the model is reasoning about the situation and why it's making the decisions that it's making. That would be a huge improvement over the black box nature of current deep learning models.
And it would be more robust to adversarial examples, because the model would be relying on its understanding of the underlying semantics, not just on the surface level features of the input. It wouldn't be so easily fooled by subtle rewording or noise.
This all sounds incredibly promising, but also incredibly challenging. What are the biggest obstacles that we need to overcome in order to build these kinds of AI systems?
I think the biggest obstacle is the lack of data. We need more data about how the brain works. We need more detailed neuroimaging studies. We need more computational models of brain function, and we need more collaboration between neuroscientists and AI researchers.
I disagree. I think the biggest obstacle is the lack of good algorithms. We need new algorithms that can represent and manipulate knowledge in a way that's both computationally efficient and semantically meaningful. We need to move beyond simple pattern matching and towards true reasoning.
I think the biggest obstacle is the lack of a unifying framework. We need a framework that can integrate different levels of abstraction, from the low-level details of neural processing to the high-level concepts of symbolic reasoning. We need a way to translate between different coordinate systems and to represent the relationships between different events in space and time.
Okay, let's take those obstacles and turn them into potential research directions. From your perspective, Otto, what are the most promising avenues for future research in neuroscience that could inform the development of more intelligent AI systems?
I'd say we need more research into the neural correlates of consciousness. If we can pinpoint the brain regions and neural circuits that are responsible for conscious experience, we might be able to incorporate those principles into our AI systems. Imagine AI that doesn't just process information, but actually understands it.
That's actually been something I've considered quite a bit recently. That could potentially lead to memory systems that are not just able to store and retrieve information, but that can also experience and understand its significance. The implications are tremendous.
And from my perspective, we need more research into neurosymbolic AI. We need to explore how to combine the strengths of neural networks and symbolic reasoning in a way that overcomes their individual limitations. How can we build AI systems that can learn from data, but also reason about that data in a logical and consistent way?
I think we need to focus on developing more sophisticated mathematical frameworks for representing and manipulating spatiotemporal relationships. How can we build AI systems that can seamlessly translate between different coordinate systems and reason about the world in a way that's both flexible and precise?
Those are all fantastic suggestions. It sounds like we're on the cusp of a major shift in AI research, moving away from purely statistical models and towards more biologically inspired architectures. It's an exciting time to be working in this field.
Absolutely. And I think the violent tendencies study is a valuable reminder that we need to be thinking carefully about the ethical and societal implications of our work. We can't just blindly pursue technological progress without considering the potential consequences.
Agreed. We need to be building AI systems that are not only intelligent, but also responsible and trustworthy.
And that requires a fundamental shift in how we think about intelligence. It's not just about building machines that can solve problems. It's about building machines that can understand the world and act in a way that's consistent with our values.
Well, this has been a fascinating discussion. Thank you all for sharing your insights, and thank you to our listeners for tuning in. We hope you've enjoyed this episode of Cognitive Spirals. Join us next time as we continue to explore the latest research in consciousness, cognition, and machine intelligence.